Everybody, thank you very much for your invitation, and I'm very happy and very delighted to be here in your conference. During this conference, I will speak about my topic, but before going to my topic, I'm going to talk about myself. I'm an educational manager of a company, Aircraft Composite Incorporation in Malaysia. My name is Elias Rajbaran. I received all my education in Malaysia, UPM, University Putra Malaysia, and my field of study is materials engineering. And my current study is about the recycling of materials. Thank you very much for Xiamen for your invitation. I'm very happy to be here. Hopefully next year or next coming conferences, I will be there. I will visit the beautiful city Xiamen in China. The topic and the title I'm going to talk about is recycling solar panels and refurbishing carbon fibers with nanochemistry. During this picture, you can see the solar panels. Every corner of each city, if you go and we cross the street in somewhere like this for the residential areas, also all the areas in the world, we will see the solar panels. Then what happened to them in the future if they are accidentally something happened to them? Perhaps throwing the stones, perhaps something like this, throwing out or something like this, how we can recycle them, or we should accumulate them for the future, and how we can use them, and what happened to them in the future. It's very important because nowadays they are new and brand new, sounds like the really tip-top and fantastic design and lovely faces, but what happened in the future for all them? Before going to the introduction, I'm going to talk about the sustainable approach for renewable energy technologies. During this approach, we can find a solution for the future of everything, especially nowadays. We're going to talk about the solar panels. For the solar panels and how we can recycle it and how we're refurbishing of them with nanochemistry, that's very important and really crucial. Sustainable particles such as the nanocarbon can be very useful and can be very sustainable to use it, and we can use it for several years. And we can use the durability of each material, especially for the solar panels. Nanochemistry, we know it better than everyone. This is a branch of chemistry and also offered a unique solution for environmental changes. Nowadays, if we cross the world and also if we go to the cities, we can see the cars, and we can see the vehicles. Most of the vehicles going to use the renewable energy. And the renewable energy technology can be important because of the future. We can see the high-speed cars, even they are using the batteries. The batteries also consuming energy from solar panels. So technically, the solar panels play an important role for all of us in the future. Then also the recycling the batteries also can be important. And how we can recycle the solar panels and how we can recycle the batteries also can be very, very crucial. But how we can manage it, it's very, very interesting topic. Solar panels. This is a way to convert the sunlight into electricity through the photovoltaic effect. This is photovoltaic effect that's very important, and convert the sunlight. This is a definition for solar panels. The solar panels can be consisting of such as the cells, also the glass, aluminium frames, and some wiring. For each of them, for the photovoltaic cells, how we can recycle it, this is another category. And for the glasses, how we can recycle it, this another category. Aluminium frames, also another category. Wiring, different story. But then how we can use it, and if we have to minimize the waste to protect our environment impact. Environmental impact nowadays is very crucial for our future. Two types of solar panels are here, monocrystalline and also polycrystalline. Here we can see both of them, and recycling of them a bit different to each other. Sorry. Here we can see the thin films of solar panels contain the cadmium. Another of them we can see the amorphous silicon. Another CIGS solar panels containing the really copper, indium, gallium, and also selenium. This is very important for all of us to be familiar with these materials, with the heavy metals. Some of them are heavy metals, and recycling of heavy metals are really crucial. Basic construction of thin film solar panels. Here we can see the surface, frame, supercell, also the backside. It can be different, and fabricating of them. First, we should know how to fabricate the solar panels, then how we can recycle them. Challenges in recycling solar panels. Current challenges can be divided into we don't have any obvious standard. We don't have any type of standard and unique standard. All the companies such as ASTM, such as DIN, there is no really unique standard that all companies and all countries also follow it. Just there are some locals by each factory they are using for this. If we are going to find one standard for this, recycling of this can be easy. Also can be a patent. For example, the recycling of company X, of just going through the company X as a producer, it can be in the future. But if a country import some products from company, for example, Y, and don't have the facilities for recycling of it, can be really face a lot of problems such as hazardous waste accumulation and environmental pollution happen to that country in the future. Industry-wide challenge, really separating backsheet, silicon, metals to achieve pure state required for full sustainability. It's very, very obvious and very, very important for all of us to know it for the industry in the future. Also, this is a big challenge. I told you how we can recycle them and what technique we are going to use. The goal we have for this process is 100% recycle them. It can be a goal. You see the title of it, it's a goal only. How we can achieve it, maybe 30%, 50%. Well, we are going to achieve it 100%. But let's see how we can see it to minimize the residual amount of it. It's very crucial, and minimize the risk of environment by keeping product out of landfill. It also, this is can be really idealistic. We will speak about this part. We will speak about that. Really keep them out of the landfill. Now, it is a solution. They are the solution, and also can be a goal for this. Create product like the downstream, like aluminium, glass, polyvinyl, or something like this. We should know it, how we can do that. Why it is important? Yeah, we can see over 35 million solar panels are just only in the United States of America. So, and also the rate of it is going up. Once the rate of them is going up, they use the solar panels. So technically, in the future, we will see a lot of and huge number of solar panels, but the solar panels doesn't work. So they really use the solar panels. We will see this, and this scenario changes the environment perhaps. Today, about 90% of solar panels are in the landfill, and e-waste can really catch a huge amount of e-waste, and we can calculate them as e-waste nowadays. The toxic chemicals and grounds of water or something else, it can be very hazardous for the future and also for the society. Some estimation predict that by 2050, waste from solar panels could be account for 10% of the total electric or e-waste in the world. So technically, we will see the huge number and huge side effects of solar panels. Also, the cadmium can be really trivial for the future and really can be really crucial how we can predict the society and predict the world out of these heavy metals like this. If the 62% of cadmium can be found in the water in the future, and that is very dangerous for the health of people. This is a prediction. This is a prediction just in next 30 years, recycling solar panels can be a part of the estimate 50 million pounds, 50 million pounds, sorry, 50 billion pounds, wow, can be reduced the amount. So it is a really good benefit. That's a very good benefit. 50 billion, it's a very huge amount of money. Maintaining green energy, also they're using the green energy positive impact on our environment. Refurbishing, really, we should offer something sustainable and refurbish, use something refurbished with it to not produce again something more. Recycling process for solar panels, also such as the glass, metals. This is a very easy steps for producing, but we should know, as I mentioned, how we can recycle them. Recycling of this is very important. Guys, it means if you are going to recycle the solar panels, you should know, and you must know, how fabricated. It is totally different to something like this. You should know everything from the scratch, from the solar panels. Then you can recycle it. It's very difficult to show us, okay, this is something here is rubbish and we should recycle it. No, you should know it is solar panels and how we can recycle it. Both technology are needed together. And here for the carbon fiber, I told you, this is using the carbon fiber. Carbon fiber can be very, very expensive, but this is sustainable. Light, high strength material, and can use it in various industries such as aerospace, automotive, and also sporting goods. For the carbon fibers, and if you use it for the solar panels, can be really recommended. Why? Because it increases the durability and also can increase the rate of exposing rate of the sending and receiving. Very high recommended for the increase the life cycles as well. And also recycling of it can be very easy. Recycling of the carbon fiber is very easy, but in the first step expensive, but investing for the future. Why investing for the future? Because the recycling of it is very easy. Definitely for everything we have some challenges. We have some challenges also for refurbishing the carbon fibers. They need advanced technology. Definitely for everything we need something advanced because we are using something modern. For something like modern, we should use also the advanced model for this pattern. The waste for the environment can be because of the non-biodegradable, but for this the potential of it for the landfill accumulation. A lot of solutions they have, but gradually, step by step, we will see. For now, perhaps it's very crucial, and perhaps it's something like really can call it as a enormous, and someone can't know it well. But if we're going for something like the epidemic and like the mobile phone in the past, if you are going to repair your mobile phone, perhaps just one or two shops are available. But nowadays, you can repair your phone everywhere, but in the future also, it is the prediction of the world. It can be like this. For the carbon fiber refurbishing process of it, for the chemical treatments, thermal process, mechanical methods, for removing the coats and resin by the different temperature, as I told you, for the thermal process, you can separate them. And we can achieve the virgin carbon fiber back to the circular economy principle. That's very possible, and in the scale of laboratory was possible. Definitely in the future, we can see that in the scale of industry, it's possible too. Nanotechnology, you know the nanotechnology, this is a vital role for the effectiveness of the sustainability. And we should try to use all of them together, the nanotechnology and also nanochemistry, also everything like this for the future of the solar panels. For the solar panels as well, we should use some solvents for this, for the recycle it, and this is very important. and to recycle of them. It's for the membranes of the solar panels. They should be the waterproof, and we should use the materials can be also the recyclable, but also waterproof. It can be a bit challenging. For the carbon nanotubes and also for the carbon fiber, adhesion of the strength is very important, and it's very crucial to use the composite materials. Increase it, because for the composite materials you can use a different range of materials and you can use a different types of materials. If you are looking for the bumper, you can use, for example, material X. If you are using material, for example, Y, for the increasing the something like this, like the strength, you can use material Y. It is the something very flexible, and we can use the different types of composites. You can use it and you can define it, and we can study with it like a case study. Case study it every research group for the academia and also the between academia and industry. The government played an important role, and in the next slides you will see the role of government for the countries by countries. You will see the private sectors and also the government, something like this. We will see this. For the case study, definitely we need huge fund. We need huge fund from the government, also the companies, and for perhaps the countries and the government of countries thinking deeply about the future of their country. If we can recycle the solar panels, we're investing for the future of the society and future of the next generation. It is really crucial, and hopefully using the renewable energy can happen like this. Yep, in the past I was talking about investing funds, something like this. Now going for the economic benefits for the solar panels recycling. Really cost saving for the future. Also circular economy models. Once you have for this, create the job, innovation, the business growth. Guys, it can be a new steps, and also the new job, create a new job according to the new demand of us. Also can be a new topic and new subject for doing research by the research institute, by the universities, by the students at the university or perhaps schools. Play the important role for this. Increase the waste can be very dangerous and very hazardous for the future. But how we can use the waste and how we can use it as a raw material can be very crucial and really important. Can be cost saving as well. If we are going to write something like writing a letter to our dean of university or work, okay, we need some fund, we need some project like this. I think if we mention that the cost saving increase our chance. For this, it's very important, the solar panels recycling techniques. I told you, for the recycling techniques, we should think about the very obvious and very interesting topic. It's like this. If you want to recycle it, you should know how to make it, how to produce it. Without that, it can be very challenging. It means the company produce it. That company can recycle it. We need a standard as well. The carbon fiber refurbishing methods. For this case, refurbishing carbon can be really very showcasing of how we can use the high performance materials. So increase the durabilities by using the carbon fiber and also recycling of it. The nanochemistry applications in materials refurbishing. It is really somehow, you know it. For the nanochemistry and for the catalysts, we can manage this, we can achieve this point well. Sustainable practices. Sustainable practices, I told you, use the durable materials and also use the eco-friendly techniques can help us to achieve this goal. Advanced recycling technology, advanced recycling technology, it's really good and really vital to use this part. Really use it. This part can be very important because it is we are going to a new chapter. We are going to a new chapter of the industry, the solar panel, and use the solar energy. So definitely we need something advanced. Yeah, by nanotechnology, we can achieve the durable materials. It's very easy. It's very easy, and without thinking deeply, we can get it when we can see it. Oh, the size of everything going to smaller, but I know, and you know, it's really the size of mobile phone these days are going to increase. Yeah, there's something really going to decrease and increase, something like this. The circular economy principles. If we go for everywhere, we will see the net zero, the circular economy, something like this. We need some models, how we can control the waste materials and the closed-loop system, something like this. If we go for the IKEA system, and if we go to the McDonald's system, if the McDonald's also going to recycle its materials. For the IKEA, this is the future of IKEA as well, going to recycle the products of IKEA in the future. And also in the future, IKEA as well is going to use their own materials, so they use the second-hand materials of itself for producing the new product. Fuel cell for stationary power generation. We will see the guys in the future. Oh, now here you will see this is in Norway. Here in the Norway, you will see this is something like the power generation by solar panels. This is good for also the residential areas, also businesses, also for the remote areas. You know that Norway, it's a country far from the sun, but this is solar panel are different to the power of sun. Just you know, slightly of each light of sun can be important, can be very good and work it well. Here again, going to review this for the remote locations. This is how we can use it. This, you know, the solution better than everyone. This is sun ray to the solar panel and change it to the energy and back to the houses. Fuel cells are supportable for the mobile devices like drones, electronic devices, mobile devices, something like this. Here we see the batteries everywhere as well. Discuss about batteries, discuss about the solar panels. If we add CNTs, what happened? Carbon nanotube. If we add CNTs, what happened to that? If we add CNTs, we will see the connectivity getting increased, and also the conductivity also increase. So it can be beneficial for the industry of solar panels as well. But it is expensive. I told you, it is expensive, but saving money for the future. By adding CNTs, means carbon nanotube, using this nanotechnology and nanochemistry, we can increase something like the mechanical strength and also the stability. This is very important, and we're gonna achieve this one. But just by changing materials, by changing the material like this, by adding some material like CNT, carbon nanotube, we can achieve very good goal. By adding also CNTs, the carbon nanotube, or using nanochemistry, reduce the contact resistance for the fuel cells. So the durability of the solar panels can be increased. Also the connectivity getting increased and stable. This is the best method for this, but expensive. Think about future. I told you, and in the past year, I told you about the governments in the world. Some government in the world, they are going to control and they are going to invest money for this. Here you will see the government of Japan, one of the best one to invest money for this. And some governments like this, you will see this, but the government of Japan is really invest huge money on that matter, I told you. For the fuel economy, you will see this is the economy. getting increased, and there is no prospection for the right now. And here you will see my statistical data. It is just in 2014, and hopefully for next 10 years getting better. The future prospect for this matter, if we are going to speak about the future prospect of it, it can be clear. We should be optimistic for this matter. We should think about the future of it. A lot of advancement method by the research centers. By refurbishing the carbon fibers, we can increase the durability, and also we can access to the better raw materials, carbon materials. And for this case, renewable energy, sustainable practices, something like this, we will see this. And nanochemical solutions, we can achieve it by the future prospect of it. In conclusion, recycling solar panels by the refurbishing offers sustainable solutions for the renewable energy sectors. Here we will see this, something like this, refurbishing process, I told you. And better now listen to your lovely comments and also your lovely solutions. As I mentioned in the last part of the conclusion, let's work together. Let's work together for the future. That's it. And for refurbishing and also for recycling, for all of the cases, the H2 hydrogen, we should be careful about that part. And also, guys, safety first, please. I wish I were there, Xiamen. I wish I were there. And thank you very much for this time. Thank you very much for this opportunity. Hopefully next year, next conferences are there. And now this is the question and answer. I'm waiting for your constructive comments, questions. Hopefully I can answer them, and in the future we can discuss about this. This conference can be good networking for our future, for my company. And also very happy to see you. Hopefully have an interesting time and interesting moments in Xiamen. Thank you very much. 谢谢你。